Chapter 7. We'll look at the concepts that are on the Chapter 7 test. I'm going to just zip down to those quick. Graphing a rational function. I like to start by x, y intercepts, vertical and horizontal asymptote. Look for holes and then do your test line, and that'll help you to graph. Best way to graph is with a calculator, but when we're analyzing things, this is a great way to look at it. Inequalities, same thing. Set numerator equal to 0. Set denominator equal to 0. And then draw your line, A, B, C, and then pick out your test values. X equal to, X equal to, X equal to, X equal to, and then just follow what it said. If it was f of x greater than or equal to 2, then you've got to see when you put that x, is it greater than or equal to 2? And then that'll make sense. Solving real problems, rate, time. Rate plus rate equals rate, or time plus time equals time. Two formulas with the x, y problems where you have to define x, find the equations. And then I have some limits that I thought I would do. So let's do that first. Let's find the vertical, and you can stop the video and try these. All right, so I'm going to do this one, set the denominator equals 0. By the way, nothing cancels out, so we're just going to get x equal -2, x will be equal to 3, will be the vertical asymptotes. Nothing cancels out, so there are none of the holes. Horizontal asymptote, you're going to take the greatest exponent of x, which is 3x times x is 3x squared, over x times -x is -x squared. So if you cancel those out, you're going to get y equal to -3. So that's the horizontal asymptote. You want to do some more of those? I've got more of those. Go ahead and try these. And then I'll give you the answers, but you can stop this one and try them. Start. So this is going to be 0x squared, so you're going to get 0 over 3. So y equals 0 would be your horizontal asymptote for this one. This one would be 5x squared plus 0x squared. This is going to be 5 over 0, which will be no horizontal asymptotes. This one is going to be 2x squared over -2x squared, which will be 2 over -2 equals -1. Y equal -1 will be the horizontal asymptote. And then this last one's going to be 5 over -1, -5. They're good for trying. Did I skip something back here? Yes, I did a couple of these. Bill can do the dishes in 4 minutes. Bill and Sue can do the dishes in 5 minutes. How long will it take Sue to do them by herself? This one's kind of interesting because when you do the rate of this one, the rate plus the rate of Bill plus rate of Sue equals rate of both. Okay, so Bill is one job in 4 minutes, one job in X minutes, and one job in 5 minutes. Well, you're going to see something really nasty happening here. 1 over X is going to be 1 over 5 minus 1 over 4. 1 over 4 is bigger, so this will be negative, and X can't be negative minutes. So you probably had this feeling that something was wrong with this problem, and you were right. They both have to do it in less time for this to be a meaningful problem. So since it took them longer to do both, Sue isn't only a bad influence, she makes it so you cannot solve this problem. I did expand it. If Sue and Bill can finish in 3 minutes, can you figure it out? Okay. Then I think the answer is there. Here's a paddle problem. I'll let you think about this one. This is the one where we had time going downstream plus time going upstream will be equal to the time total. And time is distance over speed. So you can paddle 5 miles per hour on a lake. It takes the same amount of time to paddle upstream as it takes to go downstream. Oh, that's interesting. So they got a completely different relationship here. The time to go upstream is equal to the time to go downstream. Well, how can that be? Well, it's because they have different distances. So the distance going upstream is 4 miles divided by 5 minus t, or speed of the current, is equal to 16 miles over 5 plus the speed of the current. And I'll let you finish that one. And if you go to these 3, I'm going to let you try those. Leave these up to you to figure out, and you can use your calculator too if you need to. But 1 and 2 are great examples. 3 is one of my absolute favorites. Find the area equation of the field and the radius of, using the radiuses of the semicircle. The perimeter is, which consists of the circle, and let's see, find the area as a function of r. So if you look at the area of this, it's going to be one semicircle plus another is just going to be pi r squared. And then the area of this is going to be x times 2r. And so there you have that. The perimeter is 0.25 miles. So we're going to try to eliminate one of these variables. I'm going to get rid of x. Okay? So to do that, the perimeter is going to be 2 pi r's, because that's the distance going around here and around here. And then we're going to have 2 x's to go around. And they said that's going to be 1/4 of a mile. Okay? So if you want to get this equation and you want to eliminate x, I'm just going to divide everything by 2, and I'll get pi r plus x equals 1/8. And I'm going to take out an r, and get pi plus 1 1/8. So r is going to be, right, 1/8 times 1 plus pi, which is going to be equal to 1/8 plus 8 pi. That's what x is. I think I did this wrong. Let's try this again. 2x is equal to 1/4 minus 2 pi r. Here we go. And then when we divide by 2, I'm going to get 1/8 minus pi r. Now that's what x is. So wherever we see x, we can replace it with 1/8 minus pi r times 2r. And this is the equation for area in terms of r. And all the x's are taken out of it. Very good. And then these two, you can use the methods that we looked at before. Now, here's a bunch of other practice problems if you want, and they're kind of nicely written. Unfortunately, I don't see the answers, but if you want to find out any of those, I can help you with that. But these are great practice for setting up these relationships that in the future you're going to do some calculus with. That ends Chapter 7. Chapter 8, logs, coming up next.